So if I start here with -1, it says for x squared minus 16 over x squared plus 3x minus 4, find the following. So when it's in this form, I call this standard form. I don't know the exact terminology. Standard form is really good for identifying the degree of the numerator and the degree of the denominator. It's also very good at finding the y-intercept. But what's it not good at? I can't identify the holes, the vertical asymptote, the x-intercepts. That has to be in factored form in order to identify those things. So first things first, if you get one that's in standard form, write it in factored form and have both forms available. And I would tell you to do the other thing if you're given factored form first. Some of you guys may benefit if you put it in standard form, depending on how well you can identify the degrees. So if I need to factor this, how could I factor the numerator? That's the difference of perfect squares. Is everyone okay with that, or do I need to do more explanation for difference of perfect squares? And for real, speak up if you do. My everybody that I have 6th period that I have for basketball, they were complaining. They said, "I don't have a clue what you're doing." I said, "Well, you didn't speak up in class." "Oh, well, I'm just telling you. I'm confused." So, if you're confused, talk now so I can help you. Okay, the denominator, x squared plus 3x minus 4. I can factor that by sight. If you can't, you may need to do the a times c method. I can show a times c if I need to, but that is x plus 4 times x minus 1. Do I need to do the a times c method for you guys?
What is that?
A times c?
Yeah.
Okay, so anytime the leading coefficient is not 1, I always do a times c. But you can do it every time. So here's how it works. So we call it a times c because this is ax squared plus bx plus c. So a times c would be 1 times 4. That gives me an answer of 4. So this is kind of like my scratch work over here. What are the factors of 4? 1 times 4 or 2 times 2. That's all I can list. Now I want to rewrite the b term, 3x, by combining some of these factors. So combining means it could be added or subtracted. So which ones of these factors that multiplied to be 4 combines to be 3? Positive 3. So this would need to be a positive 4 and a negative 1 because 4 minus 1 is 3. So we can rewrite the b term to be 4x minus 1x. So I just rewrote the b term using these factors.
You can use that when the coefficient is.
You can use it every time. I do it every time when the coefficient's not 1. If the coefficient is 1, I can do it by sight. So again, it depends on how good at factoring you guys are. Normally I do a 1-week review on factoring when I teach pre-cal, but I didn't know how much time I had because it was AP this year and it's different, so we didn't do it. Anyways, once I have 4 terms, I can factor by grouping. So I group the first 2 terms together and the last 2 terms together. And then when we factor by grouping, the GCF of the first 2 terms is x. If I factor an x out, that leaves me with x plus 4. GCF of the last 2 terms is negative 1. If I factor that out, that leaves me with x plus 4. In order to factor by grouping, the parentheses must match. If they don't match, grouping did not work. But they do match. So this worked. So this factors to be what's in front of the parentheses, x minus 1, times the matching parenthesis, x plus 4. Which is what I got by sight, right? So depending on how good you are at factoring, like some people, I can't do it by sight, and that's fine. Just do a times c, right? It's a algorithm that you could use. Questions about anything so far? So this is factored form. So now that it's in factored form, first we want to identify where are the holes. That's where I would start. Do I have any holes? I do. How do I know where the holes are at? Common factor. So because there's an x, sorry, I did the wrong place. Because there's an x plus 4 in the numerator and in the denominator, that's going to make a hole. So the hole is at x equals negative 4. Right, think about solving that. So the hole's at x equals negative 4. So now once I've identified where the holes are at, then the next question is where are the zeros? That's just the x-intercepts. So where do I find x-intercepts? Numerator. Whatever didn't cancel in the numerator gives an x-intercept. So the x minus 4 will be my x-intercept. So think about solving that. X minus 4 equals 0. So the x-intercept is at x equals 4. So the first question here, when it says find the zeros, the zeros are at x equals 4. Is everybody good with that? Next question, where's the y-intercept? So there's different ways you can do it. For me, when it's in standard form like this, the y-intercept happens when you plug in 0 for x. So all these terms go away. So I'm left with negative 16 over negative 4. Well, what is negative 16 divided by negative 4? Positive 4. So the y-intercept is at 4. Right, think about plugging in 0 for x. Questions there. Next, where is the vertical asymptotes? Those are given by the factors in the denominator that didn't cancel. So this one didn't cancel out, so it's going to be a vertical asymptote. So think about setting it equal to 0. X minus 1 equals 0. That means x equals 1 is my vertical asymptote. And now then, where are the holes at in the graph? So we haven't talked about how to do this specifically yet, but we can. We know the x value of the hole, but we don't know the y value. So here's how you can find it. Think about up here, my factored form. So this was the part of the graph that gave me a problem, that gives me a hole. Well, if I cancel it out in the numerator and denominator, then I have a depressed polynomial, or I have a depressed rational function, right? It's a degree lower. But if I cancel this out, my graph has the same behavior as this graph at that point. So what we can do is, because we know the hole is at negative 4, and these are the parts that give me a problem at negative 4, then we can plug negative 4 into the parts that don't cancel. Just the parts that don't cancel. So then this would be, and I'm kind of running out of space, this would be negative 4 minus 4 over negative 4 minus 1, which is negative 8 over negative 5, which is 1.6. Which means the ordered pair where the hole occurs is at negative 4, 1.6. Is it okay with that? So the way they explained it differently. They plugged in values that are really close to negative 4. Think about the limit. So what was it approaching from either side? So when they plugged in negative 3.999, they got really close to 1.6. If they plug in negative 4.001, they get really close to 1.6. That's a different way to explain it than the way I did, but they both work. I've never explained it that way. whichever way you like better. I think mine's less work. And then E, are there any horizontal asymptotes? So how do we check for horizontal asymptotes? And sorry, I know this is a jumbled mess, but I'm trying to scroll and reveal. We look at the degrees of the numerator and the denominator. So standard form's fine for that. The degree of the numerator is 2. The degree of the denominator is 2. So the degree of the numerator is equal to the degree of the denominator. Those notes we have over there. That means I have a horizontal asymptote at y equals the leading coefficient divided by the leading coefficient. So this time that would be y equals 1 over 1, which is just y equals 1. So the horizontal asymptote is at y equals 1. Ratio of the leading coefficients. They say leading terms. Questions? To evaluate f of x at an x value to the left and right of the vertical asymptote to determine whether f is going to positive infinity or negative infinity. So what this means is we know we have a problem with the graph at x equals 1. So if you think about it graphically, here's my graph. If I go to where x equals 1, right here's a vertical asymptote, and I know my horizontal asymptote is at y equals 1. Right, so the real question is, like right here, is it above the x-axis and then goes to infinity, or is it beneath the x-axis and goes to, like, there's two options, right? Let me say this again. On the left side of the vertical asymptote, it could do one of two things. It either tends towards the asymptote and goes down at the vertical asymptote, or it's tending towards the asymptote and goes up. It has to do one of these two things. And on the other side of the vertical asymptote, it's the same idea. It can do one of those two things. So there's different ways to explain how to find it. What they are telling you to do is, in your calculator, plug in some number to the left. Like plug in some x value. You can pick the x. You could pick a half or 3/4. And find out what are the y values. If the y values are getting very negative, then we know the graph's going to do this. If the y values are getting very positive, we know the graph is going to do this. I just want you to plug in and check. That's one way you can do it. Here's another way you could do it. This is the way I think about it. I know the y-intercept's at 4. Right? And I know the only x-intercept is at 4. So I don't have to plug in points. I know what the graph looks like from these critical points. If it was down here, what would have to happen? I would need an x-intercept. And I would have a negative y-intercept that doesn't exist. So I know up here the graph has to look like that. Now what happens on the right side of the vertical asymptote? Well, again, two options. It could be up here. Well, if it is, I won't get the x-intercept. So it has to be on the bottom part and then crossing there. You see how I did that with my points? Now, one thing that I see happen all the time, and I don't know where the disconnect is, like some people can take this information, so say those are my asymptotes, and they'll draw it like this. And they'll say, there's my rational function. How do I know this is not the answer? What is this not? A function. It does not pass the vertical line test. Everything we're doing is going to be a function. So it can't be stacked on either side of the asymptote. You have to have, think about reading it like a timeline from left to right. When I read it from left to right, I've got these two options, and that's it. It can't be both, or it wouldn't be a function. Do you understand that? I'm trying to explain on the front end because I know it's going to happen on the back end because I see it every year at these breakdowns. Same thing over here. I can't have it in both. So to answer their question, as we approach the vertical asymptote, so put it in very formal terms. The limit as x approaches 1 from the left. So that would be the limit as x approaches 1 from the left of f of x is equal to. So as we approach from the left, what are the y values going towards? Positive infinity. And then the second one, the limit as x approaches 1 from the right of f of x. So as we approach 1 from the right side, what's happening to the y values? So there's their answers. Right, but here's how they did it. They plugged in points. The first way I told you, where you could plug in something that's close to 1 on the left. They found it was a positive number, so they said it was going to positive infinity. And they plugged in something approaching 1 from the right, and they said that it was a negative number, therefore it was going towards negative infinity. Different ways you can get there. When the key features tell me what the graph looks like, I think that's quicker. But it doesn't always work. So the way I just showed you, sometimes you're missing features. So it doesn't work every time. And sometimes you have to plug in points. But here, I didn't have to. So I was going to show you how to do it without having to. And then they said, using all your information, draw a rough sketch of the graph. So you can see here, the y-intercept. The one thing that I didn't graph on my graph is I didn't put the hole in there. But we knew where the hole was at. It was at -4, 1.8, 1.6. So there's the hole. It tends towards the horizontal asymptotes at its extreme values. And then we have a vertical asymptote here. The only thing they didn't check for was if the graph crossed the horizontal asymptote. And we'll do that in the Rady problems today. Man, I took a lot of time. How do we feel? I try to do it more slowly. Any questions on any part of that? Okay. So like I said, that Rady, it gives you a good overview of how to work the problem. I'm just going to be honest, my brain probably doesn't go in the exact order that they do it in. But there's nothing wrong with their order. But here's where I start. I like to start by looking, are there any holes, x-intercepts, and vertical asymptotes? That's where I'm going to start. So this is already in both. It's in factored form and in standard form. So that's nice. Are there any common factors that I can cancel out in the numerator and the denominator? There's not. That means there are no holes. Which means all the factors in the numerator give the x-intercepts. So the x-intercept is going to be at 4, 0. And the vertical asymptote is going to be at x equals -2. Questions there on anything I just did? Next thing I'm going to identify is the horizontal asymptotes, or horizontal asymptote. So the degree of the numerator is 1. The degree of the denominator is 1. So because the degree of the numerator equals the degree of the denominator, I have a horizontal asymptote at y equals a ratio of the leading coefficients. Y equals 1 over 1, which is y equals 1. Also know the y-intercept is at -4 over 2. Just a ratio of the constants. So the y-intercept is at 0, -2. And then the last thing I want to check, the thing that they didn't check yet, is I want to know, do I cross the horizontal asymptote? So because the horizontal asymptote is at y equals 1, I can plug in 1 for y. And I can check if it crosses. So I'm just plugging in 1 for y. set up a proportion and cross multiply. So that says x minus 4 equals x minus 2. If I get my x's on the same side, they cancel, and I'm left with nonsense. So because I have nonsense, I know it doesn't cross. So it doesn't cross the horizontal asymptote. So now I really have all the stuff I need in order to graph this line. So the horizontal asymptote is at y equals 1. There, I'm drawing that. The vertical asymptote is at x equals negative 2. Here I am drawing that. I have a y-intercept at negative 2. That means the graph is going to cross here. I have a x-intercept at 4, 0. That means the graph's going to cross here. And now can you guys visualize what the graph looks like? On the right side of the vertical asymptote, that's the one I have points for. So I know the graph has to look like that, tending towards the asymptotes. Is everybody good with that? What about the left side of the vertical asymptote? Well, there's only two options. It could be up here or it could be down here. Correct. That's exactly the way to reason that. It can't be this one, because if there was, there'd be another x-intercept that doesn't exist. I know this is the only x-intercept, which means the other part of the graph has to be, let me erase. It has to be that piece. So I'm just going to redraw it with the correct color. You see how I reason through that? If you're not sure, that's where you can plug in an x value. So because the vertical asymptote's at negative 2, pick some point to the left of that. Pick negative 3. If I plugged in negative 3, negative 3 minus 4 over negative 3 plus 2, this is negative 7 over negative 1, which is 7. Which means I plugged in negative 3, I got a y value of 7. That means the graph has to be happening up here, above the horizontal asymptote. That's the way you can do it, by plugging in. Questions? Do the next one. I distributed the numerator to get it in standard form. Because I'm fixing to have to do long division. to find my slant asymptote. I'm just waiting on everyone to get to this point. Which I got about probably 30 seconds left before we got to start going because y'all need to see more problems. Okay, so look at the information I already have up there. Is everybody good with there being no holes? Is everyone good with the x-intercepts at -1 and 3? Is everyone good with the vertical asymptote at x equals -2? Is everyone good with the y-intercept being at -3/2, which is 0, -1.5? The degree of the numerator was 2. The degree of the denominator is 1. So because the degree of the numerator is greater than the degree of the denominator, I have a slant asymptote at the line y equals the answer to our long division question. So I have to do the long division this time. So the numerator, I distributed it, and I've got it circled up there in purple. So the numerator is x squared minus 2x minus 3, and that's going to be divided by the denominator, which is x plus 2. Now to do long division, I take my first term and I want it to match the first term here. So x times what is x squared? That's going to be x times x. So then I have to distribute. X times x is x squared. X times 2 is 2x. So now then what do? I have to subtract these values. Right, so let me write it this way. This should be 2x. Then we change every sign. So this cancels. And I am left with -4x minus 3. Now I've got an x, and I want it to be -4x. So x times what is -4x? And I can really stop right there. Like, you can keep doing the long division if you want to, but that is my slant asymptote, x minus 4. I don't care what the remainder is. I don't care about anything else. So my slant asymptote is at y equals x minus 4. So normally I would check if it crosses the slant asymptote, but that's going to take too much time. So I'm just going to ignore that this time. That's a very minor detail. So if I had to graph all of this, the x-intercept is at -1 and 3. The y-intercept is at -1.5. The vertical asymptote is at x equals -2. And now this is the one that I should have probably made my graph a little bit more detailed, because the slant asymptote is at x minus 4. So think about graphing that line. The y-intercept's at -4, and it has a slope of 1. So you could rise 1, run 1, rise 1, run 1. So just if I was very detailed, I wouldn't have to know this. But for me, I know that it's going to cross the x-axis at 4, 0. The slant asymptote is. So think about here. That's my slant asymptote. And I'm going to extend my vertical asymptote. I know, guys, I'm a disaster when it comes to drawing this stuff. Especially on my iPad. But I try to record it so you can see it. So if you get confused about what's going on, stop me. So there are two pieces to this graph. There's what happens on the right side of the vertical asymptote, over here. And what happens on the left side of the vertical asymptote, over here. I have enough points to see what's happening on the right side. It has two options. It could either be up here and then follow the slant asymptote, or it could be down here and follow the slant asymptote. Which one of those is it? It's above, right? Because it has to go through all these points that I found. So my graph will tend here above the slant asymptote. Now then, think about on the left side of the vertical asymptote. There's two options. It could be above the slant asymptote and then go up like this at the vertical asymptote, or it could be stuck below the slant asymptote and then go down at the vertical asymptote. It's the second one because there are no more x-intercepts. So again, I know that that's all over everything I drew, right? But I'm running out of space. I don't really have any other option.
So, for the slant asymptote, will the slope always be 1?
No.
Or how do you figure that out? It's just that?
The equation of this line. Remember, it's in slope-intercept form. Y equals 1x minus 4. Y-intercept's negative 1. Or sorry, y-intercept's negative 4. Slope is 1. If that's a 2 or a 3, that's your slope.